Okay, so now we are going to start with the mechanics, the resultant forces, and with the resultant forces, just as we have resultant vectors, we also have resultant forces. Now, when we talk of resultant forces, it's the summation of all the forces. Okay, so for instance, if I have forces, so force one, force two, force three, all the way up to force n, then the resultant force of all these forces is going to be the summation of the forces. So it's going to be force 1 plus force 2 plus force 3 all the way till we get to the force n. So for instance, if we take a look at this example over here, so if I have force, if I have these three forces, so force 1 giving us 3i plus 4j, force 2 giving us negative I plus 2j, and force 3 giving us 7i minus j. And we've been asked to find the resultant. So we have to find the resultant force of force 1, force 2, and force 3. All we need to do in this case is just sum up the three forces over there. So the resultant force is going to be force 1, which is the 3i plus 4j, force 2, that is negative I plus 2j, force 3, that is 7i minus j. And that is going to give us, so to add these forces, we add according to components. Okay, so we add the I component, then we add the j component. So we are going to do 3i plus negative I plus 7j. So if I do 3i plus negative I plus 7i, not j, 7i, I'm going to get 9i. Then we add the j component, that is the y component. So the 4j plus 2j plus negative j. So 4 plus 2 minus 1 is going to give me 5j. So the resultant force for force 1, force 2, and force 3 is 9i plus 7j. So this is the answer, and we're done. Okay, now let us take a look at this second example over here. Now with this example, it says that we should find the magnitude. So we are to find the magnitude and the direction of the resultant force F1, F2, and then F3. So the F1 is giving us 3i plus 4j, F2 is giving us negative I plus 2j, F3 is giving us 7i minus j. So you realize that it's the same forces that was given to us over here. Okay, now, but then this time around, they're asking us to find for the magnitude and the direction of this resultant force. So first, we will just find the resultant force, and just as we were doing for vectors, we will just find the magnitude of the vector, then we'll just find the direction of the vector, and that is all. So first, we've already done the resultant force to get 9i plus 7j. So now to start with the resultant force, now to find the magnitude of a vector. So if a vector is given of the form maybe x, y. So if this is a vector, okay, thing, and I want to find the magnitude of the vector v, now we know that this is equal to the square root of the x component squared plus the y component squared. And that is exactly what is being used over here. So we are going back to refer to how to find the magnitude of a vector from vectors. So it is going to be the x component squared plus the y component squared, that is the 9 squared plus 5 squared. Then we take the square root of that. So the answer is going to be the square root of 106 units. So you can take the decimal for that as well. But I leave my answer as the square root of 106 units. Then to find for the direction. Now, if I plot this over here in the plane, now I have the x to be 9, and I have the y to be 5. So this is This is the y-axis, this is the x-axis. So I'll just locate x9 somewhere over here. Then my y is 5 is somewhere over here. Then I can draw a vector that will intersect at this point. So I draw a vector that intersects at this point over here. Then I find this angle. So now remember that anytime you have to find the direction of these angles, now anytime you are calculating the angle of a bearing, okay, we always start from the north. So this is where we have the north, and the north is always 0 degree, and we go in the clockwise direction. So this is 0, this is 90, this is 180, this is 2, this is 270. So we start from the north. This is the north, this line over here, the positive y-axis, that is the north. Then now we move all the way till we meet our line over here. So in this case, what we are looking for is this angle. What we are looking for is this angle over here, okay? But then we are going to find the angle down here. We it's always advisable to find the angle in relation to the x-axis. So I will find the angle between the line and the x-axis. It is always advised to do that. If you find the angle over here straight ahead, that is the angle between the line and the y-axis, it will not be wrong, but then it is always advised for you to find the angle between the line and the x-axis. So in this case, that is exactly what I'm going to do. So now when you take a look at this over here, this is a right angle triangle. This is a right angle triangle. Okay, I have a right angle triangle over here. Well, this is my angle, that is my theta. Then this side over here is the opposite. So in this case, you realize that the opposite is going to be 5. So the opposite is the same length as this line over here. That is the y-axis. And the adjacent is 9. The adjacent is from here, is from the 0, 0 till you get to the 9. So now when you take a look at this, I have a right angle triangle that looks like this. So where this over here is my theta, and I have 9 over here, I have 5 over here. Now we are to solve for the angle theta. So to solve for the angle theta, now I can use the tan to write this. So now this is going to be the tan of theta is equal to, now the opposite is 5, the adjacent is 9. So the opposite is 5, the adjacent is 9. Then because I'm looking for the theta over here, I take the tan inverse of both sides. When I take the tan inverse, I get this. So I get theta is equal to the tan inverse of 5 over 9. Then, now when I punch this on the calculator, I get theta is equal to 29.05 degree. But that is not going to be our answer. Now this angle that we've just found over here is for this angle. It is for the line and the x-axis. But then we start measuring the angle from the north. So it means that we are supposed to measure the angle from here till we get to this line. Now this whole angle over here is 90 degree. This whole angle over here is 90 degree. And this theta over here is 29.05. So if I want to find for this angle, all I need to do is to subtract that angle from 90, because the whole of this angle is 90 degree. It's a right angle triangle. Sorry, this is a right angle, just a right angle. Okay, the first quartile over here is 90 degree. So this angle over here is 90 degree. Then this theta over here is 29.05. So I just subtract the 29.05 from the 90 degree, and the answer is going to be 60.95 degree. So now this is going to be the answer we are looking for. So the answer to this question is 60.95 degree.